All right, let's see how to analyze a connection of resistors with a cell. So, accordingly, here the question here says in the electrical circuit below, what is the value of the current through the 1 ohm resistor? In this electrical circuit below, what is the value of the current through the 1 ohm resistor? This is a JAMB question 1979, and this is the circuit here. The 1 ohm resistor is here. This is where the 1 ohm resistor is. So they say we should calculate the current. So we should calculate the current through that particular resistor. Current I. Are we there? Okay. So before you are able to calculate the current through that resistor there, the first thing you have to do, you have to analyze uh, these resistors that are here. So let's look at these four resistors: one, two, three, four. Each of them is a 3 ohm, 3 ohms, 3 ohm resistor. So let's see how we can simplify that network. For here, this is a series connection. From here to here is a series, because if you see the head of this one is connected to the tail of this one. Series connection is when the resistors are connected end to end. So you see the beginning of this one connects to the end of this one. So this and this are in series. Same goes with the upper 3 ohms and this other 3 ohms. They are also in series. So if we simplify that, however, this one two that is in series and one two that are in series, both of them are in, these two branch are in parallel to each other. But first, let's do the series, analyze the series one. So according to resistance in series, R33 will be what? The equivalent there will be 3 plus 3, which equals to 6 ohms. Same for the second R33. Second R33, which is what? 3 plus 3, which equals to what? 6 ohms. So I'll redraw this circuit now. If I redraw it, this circuit will become something like this. This circuit will become something like that. Okay, then okay. So this is what the circuit now becomes. So these two resistors that are in series, you add them and it becomes 6. So you become one resistor here, 6 ohms. And then this other one too, when you add them, it becomes one resistor here, 6 ohms. So you see how I've resolved that. Now you can see that this branch here and this branch here are in parallel to each other. The reason we say parallel to each other is that they share common terminal. You see the head of this one is sharing this node here with the head of this one, and the tail of this branch is sharing the same node with the tail of this other branch. So like this is parallel. So when you finish adding this one to be one resistor, you now see that 6 ohms is parallel to 6 ohms. Are we there? So the next thing we do, we are going to resolve these two resistors, 6 ohms and 6 ohms, that are in parallel. We are going to resolve it that are in parallel. So parallel 1 over R66, that's resistor 6 and 6, will be 1 over what? 6 plus 1 over another 6, which equals to the LCM here is 6. Are we there? So this will be 1 plus 1, which equals to 2 over 6, which equals to 1 over 3. So if you make R66 the subject of a formula or take inverse of that, your R66 will now be what? 3 over 1, which is the same thing as saying 3 ohms. So the equivalent resistance of these two that are in parallel is what? 3 ohms. It's 3 ohms. So with respect to that, I'll redraw the circuit again. I redraw the circuit. So this time around, in that parallel, this thing, it has changed to what? One resistor that is what? 3 ohms. That is now in series to the 1 ohm resistor. And then here we have our cell that is 12 volts. Okay, so if you check out, I've resolved this 6 parallel 6 to become what? One resistor. And that one resistor now is 3 ohms. And then which is now in series with 1 ohms. This is in series to 1 ohms here. 1 ohm. So having done that, we were asked to calculate the current through I1. You are asked to calculate the current through I1. Now, since this is a series connection here, the current that comes from this cell, sorry, is from this side. The current that comes from this cell will be the same current that will pass through 1 ohms and also pass through 3 ohms. Remember, when resistors are connected in series, the same current passes through them. So to get that current I, that current from Ohm's law, V equals to what? Current times resistance. Our resistance there will now be what we call equivalent resistance. And then here is the volt. We only have one voltage source, or we say equivalent voltage. Voltage source. So I now will be what? If you make I the subject of the formula here, will be V equivalent over R equivalent. And our V is what? 12 volts over R equivalent. So this 3 ohm resistor and 1 ohm resistor are in series. So the equivalent resistance there will be their addition since they are in series. So 3 plus 1, 4 divided by 4. So 4 will cancel 12, 3. So that the current there will be equals to what? 3 amps. So the current through this 1 ohm resistor will be what? 3 amps. So that's how to do this example and get along with.